I am R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we will discuss how to calculate quality factor of a cavity resonator for the dominant TE101 mode. And the quality factor of a resonator is associated with the loss factor of the cavity resonator and is given by the formula Q is equal to 2 pi multiplied by time average energy stored at resonant frequency by energy dissipated in one period of this frequency, and this Q is given by resonant frequency Fr divided by del F. And for quality factor determination, there are two factors need to be found. One is energy stored and another one is loss through the walls of the guide. And the deterioration of the cavity is because of two factors. One is the finite conductivity of the walls of the cavity and an imperfect dielectric in the space between the cavity resonators. The conductivity through not infinite is nevertheless large, so that the skin depth is small. The tangential component of the magnetic field will be assumed to be confined to a depth equal to the skin depth, which leads to surface current. And the first energy calculation, the average energy stored is given by the formula W is equal to E by 2 epsilon by 2 integral of modulus of E square dV, or we can write as epsilon by 2 modulus of E y squared dV. And since the only non-zero component of the electric field is along y direction, so substituting for the expression of y in the field equation, we get the energy is epsilon by 2 mnp by n the whole square h20 the whole square plus integral of 0 to b dx sine squared ksx plus integral of 0 to d dz square sine kz squared z integral of 0 to p dy. Here the two integrals respectively give v by 2 and b by 2, while the last one gives b. We thus have w is equal to cp square omega square n square bd by 8 pi square multiplied by h2o the whole square. And the quality factor determination, loss through the walls of the guide is given by power loss in the walls is 1 by 2 mod integral of h tangential the whole square rs ds. Here the rs value is the surface current and h tan is tangential component of magnetic field, and the surface current is given by the unit vector multiplied by the magnetic field hz, and here there is the ft is the unit normal pointing into the resonator. For the rectangular parallel pipe, we have three pairs of symmetric surface constitution from each pair being the same. For instance, we have the front face at x equal to a and the back face at x equal to 0. And by calculating in this way, the loss 2 is calculated and it is given by r h2b the whole square and multiplied by n by d the whole square plus a by d the whole square plus a by d by 4 plus a by d by 4, and 2 times a by d by 4 we get loss is equal to the surface resistance rs hz0 the whole square a by d the whole square into ab by 4, and the loss is given as like this. And finally the quality factor is calculated by the formula W into energy stored by energy dissipated. So we know the cavity resonator used in tuned circuit, EMF tubes, Klystron amplifiers, oscillators and the duplexes of radar. They are also used in microwave frequency meter. Outside power source is usually coupled to the cavity by small aperture or a small wire probe or a loop. The outer of external coupling structure affects cavity performance, and this is a consideration one must take during the overall analysis. And we know Q factor is 2 pi into energy stored by energy dissipated and denoted by the letter Q. And to determine stored energy, we can use this formula. Application of resonant cavities we have seen, and surface current density, and loss calculation also we have discussed. Thank you.